Eric Burgess here. It is desired to estimate the mean GPA of each undergraduate class at a large university. How large a sample is necessary to estimate the GPA within 0.3 at 95% confidence, given that the population standard deviation is 0.4? Alright, so first type of problem that we're dealing with, I see a lot of students, they immediately start doing just like crazy stuff with this, but the key words here is how large a sample. As soon as you see the word how large a sample, you need to be solving for the sample size. And so those are formulas that start with n equals, right? Because n is the sample size. Now, if you look on your formula sheet, there's two of these formulas. There's one for proportions, and there's one that has like sigmas and things like that. So depending on what you're given in the problem will kind of clue you into which one you need. And we see here we have a population standard deviation. So we're going to be looking for the one that's got the standard deviation in it. This one's going to have like p hat and a bunch of stuff in it. So, okay, we know we're looking for that one. Now, there's two ways to get to it. The first way is you just look on your formula sheet or you have it memorized. And so that is n is equal to, and now it's z of alpha over 2 times sigma divided by e all squared. So this is the formula that you're going to want. There is another way to get it though, and I tend to use the other way because I typically don't have this off the top of my head like I do right now. So I remember that the standard error from the confidence intervals, for whatever reason I can remember that one. And I remember that the error is equal to z of alpha over 2, this is in alpha over 2 times the standard deviation divided by the square root of n. And if you actually solve this for n, you will get this formula. Now we're just going to go with you looked on the formula sheet way, but if you like, I could do another video where I show you how to solve this. But yeah, if you solve this, you'll get this top formula, which is really handy way to do it. So you only need to remember one formula and you can get the other one. So okay, let's find these things. So first up, let's just go through the problem. So each undergraduate class, large university, how large is sample? Okay. Here's our first number, 0.3. So this 0.3 is it says how large a sample is necessary to estimate the GPA within 0.3. So that within bit is kind of a clue that this is the margin of error. They want to be within 0.3. So our E is going to be equal to 0.3. And then at 95% confidence. So this is our confidence level. And we know that the alpha is 1 minus this confidence level. So 1 minus, 100% minus 95% is 5%. And that means that our alpha is 0.05. All right. And then it says, given that the population standard deviation, well, that's sigma, is equal to 0.4. Cool. So we have all our numbers, but we still need to find a z of alpha over 2. So here's alpha. So half of this, alpha over 2, is going to be 0.025. And if you're unsure about that, you can always just type it into your calculator. 0.05. Sometimes I mess up the decimal, so it's just good to check. 0.025. So there we go. And now we need to look this up. There's two ways. You can use a calculator or you can use a chart. I'm going to use the calculator way. And then I'll show you the chart way. So on the calculator, if we're doing z-scores, those are standard normal distributions. So an inverse normal lookup will give us the z-score that corresponds with this area. So if we come in and we go to the distribution menu, we hit second distribution, come down to inverse normal, number 3, and then we choose our area. Well, we want half the area, so that's 0.025. And then a mean of 0 and a standard deviation of 1, because this is a standard normal distribution, z-scores. We hit enter, and we get this value. So we get a z of alpha over 2, and we always just take the positive one for this. 1.96. Perfect. Now let's say that we wanted to find this value, z of alpha over 2, using the chart. Well, that's pretty easy. We would just look this up in the chart and go backwards. So we'd start in the middle and go backwards to get z. So we're looking for 0.025, so let's go to a standard normal chart and look for this. So here's 0.022, 0.028. So it's going to be somewhere down here somewhere. Oh, look at that right there. Perfect. 0.025. So that corresponds to 1.9. And if we go up, 6. So here we could see it perfectly corresponds to 1.96.025. So there we have it. We found it using the chart. So that's another way to get z of alpha over 2. Now what we're going to do is we're just going to plug these guys in. So n, the required sample size, is equal to 1.96, that's our z of alpha over 2, times sigma, our sigma is 0.4, divided by, and then on the bottom, we have our margin of error 0.3, and then we're going to square it. And this is going to be equal to something. So let's go ahead and do this. So I'm going to type it in using the fraction key. So I'm going to put a parenthesis, and then alpha y equals, or this F1 in green. So it's a green key, so we hit the green button. And then we go for the first one, and then we type 1.96 times 0.4, and then we divide by 0.3. We push over, and we square it at the end. And we hit enter, and we get 6.82. Well, we'll round to 2 places, 0.83. Okay, and there's another way to enter this in the calculator. We could also do this whole inside bit and then square it if you don't want to use the fraction key. So you could do 1.96 times 0.4, hit enter, divide that by 0.3, and then square it. So we take our answer and we square it. So you just hit square, it'll put the last thing you had there, and we'll get the same answer, 6.8, blah, 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 blah. So there we go. Now here, this isn't going to work as a sample size, because how do you take 6.83 samples, especially if they're people? And so we're going to round, and we're going to round up to 7, because if we were to, let's say that we got for an answer 6.2 something, something, something. If we were to round down to 6, we would not have enough samples, because this is the minimum number of samples that we need. So we would have to actually round up in any case to 7, because if we were to round down, we wouldn't have enough. So you need at least 7 here in order for this to work. So we would say that you need a sample size of 7 in order to estimate with a 95% confidence level the mean GPA of each undergraduate class at a large university. If you wanted to write that all out in words and sort of just really show that you know how you're interpreting this, that would be great. If you have any questions about this, let me know, subscribe, and we'll catch you in the next problem.